question 3, part 1. So a particle is projected from a point on a horizontal plane with an initial velocity of 70I and 105J. We want to find the magnitude and direction of its velocity after 10 seconds. Right, so this is question 3, part 1. And it's 70I and 105J. So 70I plus 105J meters per second. Okay, so we want to know the magnitude and direction of the velocity after 10 seconds. Okay, so after 10 seconds. So if we imagine this object, just think about it, is fired up at 105 meters per second, and it goes this way at 70 meters per second, and it flies up like so, and it comes down. Now at some point after 10 seconds, maybe it's here, that's a guess, okay, its horizontal velocity will obviously be exactly the same, and it'll have some vertical velocity, which we don't know. And if we know those two, we'd be able to find then its actual direction, like that. Okay, so what we need to find is this. This is the velocity in the y direction at t equal to 10. That's supposed to be an at symbol. Right, so that's after 10 seconds. What's its vertical velocity? If we can find that, then we already know the horizontal velocity. We can find this velocity in the direction. Okay, so what we need to do then is list out the usual u, v, a, s, and t, and this is the y bit of these. Right, so it's after 10 seconds. So the initial speed, it gets fired up at 105. Final velocity is what we're actually looking for. Acceleration is minus 9.8 as usual, and the time we don't really care about. So if we have v, u, we have u, v, a, and t. So we would use the equation then, v equals u plus at. Pop the equation numbers into that. V is what we're looking for. U is 105 minus 9.8 times 10. So V just equals 105 minus 98, and that is 7 meters per second. 7 meters per second. So that's part 1. And no, that's this velocity here is 7 meters per second, okay? Going straight up. So that means, if I just drew that out, this part is going at 70, and this bit is going up at 7. This is all at t equal to 10 seconds. So what we'd like to know is, what is this angle in here? We'll move the 7 here. Okay, let's take the 7 down to there. So we basically have this triangle, and we want to find that out. So I want to find the angle first. So if I looked at, here's the angle, the side is opposite and this side is adjacent. So therefore I'm going to use tan. So the tan of theta equals the opposite over the adjacent. The opposite side is 7 over 70. So 7 over 70, so that the tan of theta is 7 over 70. That means theta equals tan inverse of 7 over 70. And if you put that into a calculator, you will get 7 over 70 is of course 0.1, so you'll get 5.7 degrees. And that looks kind of reasonable, that this would be a small enough angle, 5.7. Okay, now that tells us the angle is 5.7, but what we also need to know is the magnitude. I think we were asked for the magnitude. The magnitude and direction. So we know the direction now for 10 seconds. But what's the magnitude? So the magnitude, remember, this is like a triangle. I just draw it again. It's 7 on that side, and it's 70 on this side, and it's a right angle triangle. So that means I can apply Pythagoras to it. So I want to know what this bit here is. So I'll just call it V. So V there has to equal one side squared plus the other side squared, and it's the square root of all that. So that's just Pythagoras. that's just Pythagoras that I'm using there. So this means V equals 70 squared, which is 70 squared. So that's 4900 plus 49, and you want to find the square root of that. So 49, so that's clearly 49,049. We want to get the square root 49,049 should give us 70. Gives us 70.3 meters per second. So that means that this velocity here would be 70.3 in that direction, and of which 70 meters per second of it is this way and 7 meters per second of it is that way. So that's the magnitude, and that's the direction. So that answers that question.